Okay. But we are not going to go through the literature, the slide, page by page. I will just try to explain something I think is more important. So, when we talk about the 5G, we need to know the application. Okay, just think of the job. Someone may hire you to set up a 5G network, a factory, for example. Okay, but by the demonstration in last hour, we know it's not just about the IT portions. Basically, the 5G core, it may include two portions. One is 5G RAM. The other part is a 5G core. Okay, so that's the word of the IT. Okay, I think everyone knows the OSI, right? Open system network internet connection. OSI 7 layers. 7 layers, right? But this part probably you have never studied, right? Okay, because this part is earlier portions. But the principle is quite similar to the OSI 7 layers rules. Okay, so for the 7 layers, we may start from the IOIO, physical layer, and the data link, and TCP/IP, network layer, transportation layer, something like that, right? So 5G RAM is the same. So you will have a hierarchical, layer by layer structure. So different layers will have different definitions. They will conduct or proceed some, task. Okay. I don't ask you to remember everything, but at least we have to focus on the application first, because different applications may have different requirements. Okay. So here I give you some examples. Augmented reality. It sounds like you need to wear some AR glasses, right? That require a lot of data stream to transmit some real, virtual, videos, right? And 8K videos. These were required, the bandwidth. But for the machine-to-machine communication, they are not really take care about the transmitting speed or the bandwidth. They require very stable network connection. Okay, but they have to be the system have to be run for last a long time, like even 10 years. So I give you an example. If you put a temperature sensors in a mountain or somewhere, the bridge, you are going to monitor the bridge status. Like in Taiwan, we have a lot of earthquake, right? So you have to make sure the bridge is safe, right? So we have many, railway, like the stool of the railway, high-speed railway, right? So you need to put a sensor to monitor if any damage on this construction, right? Okay, but are you going to change the battery of the sensors? No, right? So you hope the battery lifetime can be longer, so you don't need to change. Okay, something like this. So different application may have different requirements. So that's the first thing you have to understand. So for our project, I mean, at the end of our class, you need to, create a project, which is your team map, right? So you have to think of what kind of application scenario you are going to have. So, well, that's autonomous vehicles. For this part, we consider latency reliability, right? For this, we take care about the data throughput. Okay. And for this, we are focused on the number of devices and the battery lifetime, device cost. Okay, so that's the applications. That's a motivation that why we need to have. So ITU-R is a standard regulations for this. Okay, so there is 3 usage scenario: enhanced, mobile broadband, and the other one is critical machine type communication. Okay, and the last one is massive machine type communication. So that's the 3 major usage scenario. Okay. And here talk about the NGMN, Next Generation Mobile Network. Okay, so there is a white paper to define, the system performance, and the latest version, I forget, it's 18 or why is? You need to check the white paper, then you will be able to know the spec. So once you are going to develop a system, you need to follow the standard. Okay. Like if you are going to construct a public network, are you going to use 4G or 5G? 4G or 5G? It depends. But you have to follow the spec. Okay. Like I said last week, 4G, because the spectrum, the frequency is lower, right? So the radio coverage is much wider than 5G. Okay. But 5G can provide a higher transmitting speed. So here, actually we have been mentioning this. Okay, but you have to know some basic information. Like now 5G speed is not in 5G. The maximum speed is maybe around 1 gigabits. Okay, only. But how do you? I didn't know I need this. That's byte. That's bit. In radio, we always use bit. You know what I mean? Like they say, transmitting speed, Wi-Fi, okay, 3 megabits. Okay, so you will be like a 300 megabit low. That means speed for radio, lower. Okay, but if we talk about the data transmission, I may say like a 50, it's too fast, like 1 gigabyte. That's capital. So when we talk about the radios, we use bit. When we transmission. Or when we talk about the data. So what it is? This is a bit. When we talk about protocol, we may. Okay, so but why we need to use a textbook? Because once you are going to design something, it's quite important to have some table like this. Okay, I know you may read a lot of book, and most of the time you don't feel the table is important. Okay, but just like I say, once you are going to design some network, and you look at the application scenario, and you know the requirements, because there is 3 types: machine to machine, right? Machine type to machine type, okay, and a critical machine and enhanced mobile broadband. So this table would be very good reference for you. Okay, so you can check this. If your application is sensitive to latency, right? You probably may not choose this, right? Okay. So let's download and then let's upload speed. Here, maybe we find this for car and train. What's user's experience data rate? Have you ever take? I think in Germany you do have ICE.
ICE?
I mean intercity express.
Yeah.
In France, you do have, I forget the name, the high-speed railway.
TGV?
Yeah, TGV, yeah. Okay, so how do you experience the speed? The mobile broadband in vehicles, cars. So you want to have this speed for download and upload. In the cars, usually the Wi-Fi app is about 300 megabit. Okay. So if you want to achieve this goal, to make the passenger feel comfortable for using the network, you need to provide, the network which can reach this speed. Okay, but you also depends on how many users. Okay, here they tell you the user experience requirements. So we know the individual's requirements, then we will be able to estimate the bandwidth we need when the passenger increased. But usually for a car, we may have maybe 80, right? 80 or 100 passengers in a car, right? So in a train, probably the total passenger may be around 1,000. Okay, but this is for individuals' experience. So you need to know is the requirements. Because people want to have this. Okay, here talk about system performance requirements. Okay, same. We may look at this. That we can use is same. Have this. Mobile band in vehicle, cars, trains. Okay, so the connection density, 5 active users per train, multiply 4 trains, or 1 active user per car, multiply 2,000 cars. Okay, so that's the traffic density. Why talk about this? For example, in our campus, how many students we have? I think it's around 10,000. If all students come to school, right? Well, probably not everyone come to school every day. Okay, but I think the capacity they design is around 8,000 users. 5G for 5G. Okay, but as you can see, we have only one 5G new radio station, the IP building. Okay, you go to check the building in front of our school front door. Okay, but in our center we do have a small cell. So the signal is better than the other place than in our campus. Okay. So that's user experience and the system performance requirements. Okay, so that would be kind of a standard, okay, or a baseline for you to design a system. Okay, this is like a in our classroom we do have a 2 Wi-Fi app. One, usually one Wi-Fi app will allow 16 people to access. So we have a 2, so we have a 32. So in the classroom we only have 24/6, right? So this will meet the capacity, right? So this idea is the same that we just mentioned, right? You need to consider the system performance. You have to consider the user experience requirements. Okay, that's data. You don't need to remember all this, but at least you know if you are going to design a system. Why I talk about this? Once you are going to use the 5G core, 5GC, and you have to set up your scenario, right? So some parameters you need to know. You may check this. Understand? I know it's quite boring, but I have to mention that. Okay, the rest. Okay, so you can go through the slides, but the technology changed very quickly. So I would prefer you go to check some website like a 5GAA organization, which will have a more up-to-date technology information. Okay. And I think it's very important to know this. 3rd generation partnership project. Okay. This project is continuing today. Okay. So even 5G is also under this organization. Okay, they have a new organization, but I believe this 3GPP, this called 3rd generation, but maybe you say, oh no, it's a 5th generation, but actually it's still running. Okay, so you may go to, you can visit this website to take some information. Okay, just remember, 3rd generation partnership project. Okay, this is a very important project. If you can see the original scope of 3GPP, it was established in 1998. That was a long time ago, right? was to produce technical specification and a technical report for a 3G mobile system, or we call DSM system. Okay, so it's very important to know this. Okay, so later, there's a theory trial, radio access, both frequency division duplex and time division duplex. We will explain this later. All of this is based on the specification they released. Okay, so if any update, you have to check them. Okay. I don't mean the content in this book was not important, but I want to say this content may be updated, but the most updated information should be in these two organizations. Okay, so in general, 5G use cases can be grouped into 5 main categories. Okay, that's 5 categories. So you can focus on these 5 categories for your project. Okay, like this one. First is massive IoT, right? And this one is a vehicle to X, okay, autonomous driving, and enhanced for mobile broadband. Okay, can be train, AR, VR, airplane, UHD, and time critical communication, like an industrial robot. Okay, sometimes you have to trigger the emergency stop, right? Okay, for drone, the fly devices, so sometimes they have an emergency case. You need to come down that immediately. Okay, so network operations. Okay, so you can think of one of these being your project. Okay. Okay, here give us more information about the massive IoT. I didn't know how many of you know about narrowband IoT. Have everyone heard about narrowband IoT? It is quite similar to the second generation network. So the radio coverage area is more wider. Okay, so U-bike, the sharing bike in Taipei City. Okay, so they use NB-IoT. Okay, but if you may say, why use this? Because this is a low power consumption, and it's based on the 2G technology. So that means, this is Taipei City, right? Taipei City from the Zhongxiao East Road, Section 1 to Section 7. It's about, I think, maybe 10 kilometers, right? So first generation radio, it may cover the whole city. But for 2G, it may cover, we have a many district, right? So for 2G, it may cover like maybe 7 or 8, like this. But for 3G, they may cover, it should be smaller than 2G. Okay, for 5G, it may only cover around 1 kilo, 2 kilometers. Like in our campus, right? You will have one. The next one should be nearby. Okay. But if we have one 4G radio stations, it may cover. If we have one 4G, it may cover many 5G. Something like this. So that's a kind of 2G. So it's very good for the devices like U-bike. The power consumption is low, right? Okay, so let's talk about IoT. Okay, here is another tables. Performance requirement for time critical communication. Okay, again, once we are going to simulate the network, you need your information, right? So we may simulate. We just talk about a mininet, right? Mininet. Manuel just introduced the mininet. Mininet can help you to build a network. Okay, you may have maybe hundreds of computers. Okay, but how about hundreds U-bike? Okay, which can only sending a little bit data periodical. Okay, maybe one hour or 10 minutes, something like that. Okay, so this is the reference information that you may need to put into your mininet for simulation. Okay? Something like this. Table is quite important. Okay, this is another one. Performance requirement for high data rate and traffic density scenario, like urban market. Okay. And rural market, indoor hotspot, open out. Right? Okay, that's radio stations. Okay, you will tell you the capacity. Okay. So once you know the capacity of devices, then you will be able to design the network which can fulfill with the requirements. Understand? This is talking about the radio, urban market, rural market, indoor hotspot. Like outdoor, we have a 5G small cell, right? I show you the pictures. That's or you go outside, you can see the radio. So you will tell you how many of the hardware devices you have to set up. Okay, so here like a high-speed train. Okay, so here talk about enhanced vehicular communication. So while many of the time critical communication requirements and the KPI apply for vehicles communication, there are also other specific use cases related to vehicle address in 5G. Okay, so there is automatic system issue, warning, and may interval. Okay, performance requirements for vehicle printing. Okay, so low degree of automation, high degree of automation. Okay, that's for car-to-car, vehicle-to-X application, like a roadside unit, that's a user equipment supporting vehicle to. This is like a user device equipment like your cell phone, right? Your cell phone want to communicate with your car, so that's vehicle to X. So once you are going to link your car, you can use Bluetooth or through the network. But no, it's not V2X. It's not V2net. You know the difference between V2net and the V2X? V2X means we have direct link. Okay, V2net means I will request from cloud, right? And your device, your vehicle also link to the cloud. You know what I mean? For example, you have Tesla, right? And then your Tesla is in a parking lot. How can you call your Tesla? Can you use Bluetooth? No, right? Because it's too far. Okay, but you can use vehicle to the network. Okay, so you pass this, you use your app, access to a cloud, and you will send this. Okay, anyway, this just describes the scenario. There is too many. I would not be able to explain all this in the class, but just remember that, this is the basic information that you can apply in your network design. Okay? Well, but of course you can ask ChatGPT. Okay. But once you are going to design or simulate the network, you want to make all the data are reasonable. And I think this is a good reference. And here is an API. I think I introduced this before. I think most of you know what API is. Application Programming Interface. And quality of, what's quality of E? Quality of, they have quality, here. I think this is important. Quality of experience, dynamic variety, quality of service, and policy control. So quality of experience combine dynamic variety, quality of service, and policy control. So it's a kind of a summary. Okay, 5G use case. Here I have 5G to home, in vehicle, information and entertainment. Okay, these are combined words. Okay, mass bar, truck corner. Okay, they have some descriptions, but I think you can understand this when we go for inspection, master the inspection. Okay? So that's a use case. 5G to home. Okay, here give ideas. FWA using center wave or mini wave radio. Okay, so we know mini wave can transmit more data, right? Okay, like I say, this is mini wave, center mini wave. So the frequency higher, that means we can contain more data. Okay, so Wi-Fi, you have 5G. Okay, so you may have a fiber. Okay, optical fiber. Okay, so that's That's basic architectures. Okay, so in Western Ireland, you have to fix the wireless like this. Okay, here give you we are running out of time. So for public transport users, it will be like this. Okay, you may have on the vehicle, you may have cell phone, and that's 5G radio stations, and that's train fixed radios. So 5G for in vehicle infotainments. Okay, truck printing. Right. So you may have one driver, okay, or the other truck will just follow it. Connect, healthcare, okay, Industry 4.0, business model. Okay, so let me finish this. This is, we have been mentioned this before. But there is, because we know the non-standalone, right? NSA, non-standalone. Non-standalone means the network construct based on 4G and 5G, because 4G has wider coverage. Okay, but 5G is smaller. I mean, the coverage is smaller, but it can be delivered higher quality, faster. Data streaming speed. So they do have a different configuration for this. So that is one. That's what we call anchor point. Okay, like this one is a master who is in charge to manage the traffic, something like this. So we have the option 3X. So the anchor point is 4G. And then the other one is quite similar. It's also non-standalone. Okay, but they use the 5G core. Now this one doesn't use 5G core. Okay, this is a standalone, but they use 5G core as anchor. Okay, that's different configuration. But these can happen in different application scenarios. Okay, so you just need to know this so far. This tool is more common, okay, but this is also can work. For example, you can only access to the 4G radio station, okay, but this can only link to 5G core, okay. So it will become also standalone. But you say no. It's not standalone, but because the teachers say 5G, it should be pure 5G. No. This is also called 5G. I mean standalone. You know what I mean? It's a 4G radio, but 5G core is standalone. But this one is best, right? Have a 5G core and a 5G radio. Okay? So that's a different configuration. I think you just need to know this, and that would be a good deal. But most important things is 5G. What's the difference between 4G and 5G? Do you remember? Because the 4G is together, but for 5G we separate the control plane and the user plan. That's the most important concept in 5G. Okay? Okay, I think that's the most important portion for today's class. And original, I want to go through the literature for Nokia. Okay, but it seems we don't have time. Okay, so the class will be end here today. But I think to know this is good enough. And the tables, the boarding table is quite important for your future hands-on exercise. You don't need to remember it, but you need to know where to find it. Okay? So thank you. Sorry for the delay. Is it 4:25? Okay. Any question? No? Thank you.